All right, we have spent a couple of days now solving absolute value equations. Today, we are going to talk about solving absolute value inequalities. So the problems we'll be doing today, instead of having an equal sign in them, we'll have either less than, greater than, less than or equal to, greater than or equal to in them. All right, now let's kind of keep in mind what we've done as we've solved absolute value equations. We know that absolute value means distance from zero on a number line, and we have seen that the majority of absolute value equations are going to have two solutions. There is a positive case and there is a negative case. We're going to see that a lot of that holds true as we move into absolute value inequalities. So we're going to start out today with kind of a basic introduction just to get you used to how these work, and then we'll move on to the problems that are a little more complicated. So today, what I want to do is start you out with a pretty basic inequality. So the first absolute value inequality that we are going to solve is the absolute value of x is greater than 3. The absolute value of x is greater than 3. Now you all know that in those absolute value equations that we solved yesterday, you had stuff outside of the absolute value bars which caused you to have to isolate the absolute value first. I'm going to leave that out today. So there won't be any of that isolating that you were doing yesterday. We're going to start out basic and work our way up to that. So let's take a look at what's inside of our absolute value bars. We are taking the absolute value of x. And I want you to look at and think about what this inequality is saying. It's saying that the absolute value of x is greater than 3. Now we know that this absolute value is a distance. So when it says that the absolute value of x is greater than 3, what that means is x is more than 3 spaces from 0. So when this thing says that the absolute value of x is greater than 3, it's trying to tell me that x is more than 3 spaces away from 0. So when I go looking for x, I need to be looking more than 3 spaces away from 0. So if I start to picture a number line in my head, and I'm going to draw one here on the board, more than 3 spaces away from 0. Well, 1 is 1 space away. 2 is 2 spaces away. 3 is 3 spaces away, but this says we have to be more. So I'm going to keep going. 4 would be more than 3 spaces away from 0. 5 would be more than 3 spaces away from 0. 6 would be more than 3 spaces away from 0. And so on. 7, 8, 9, on to infinity. All of those numbers would be more than 3 spaces away from 0. So on my number line, here's what I'm going to do. I'm going to come over here and I'm going to start out here from 3. Because 3 is kind of a significant number for me here. I want to be more than 3 spaces away from 0. Now 3 doesn't fit that description, so x can't be 3. So remember that I could show that on this number line. That's not a very good circle, is it? Let me try that again. To show that on my number line, I could put an open circle on that 3. To say, hey, x can't be 3. This number is not more than 3 spaces from 0. But 3.1 would be more than 3 spaces away from 0. 3.2, 3.4, 3.5, and so on down the line. So starting from 3, all of these numbers that are to the right of 3, that are above 3, would be more than 3 spaces away from 0. So this little ray that I've drawn here with an open circle at 3 and then shading to the right would show a bunch of numbers that would fit this description. So x could be anything in this part of the number line, anything. Okay, now let's consider the other direction. I want x to be more than 3 spaces from 0. -1 won't do that. -2 won't do that. When I get to -3, though, I start to make progress. I'm getting close to being more than 3 spaces away from 0 because right there I am 3 spaces away from 0. So -4 would be, -5 would be, -6 would be, so on to -infinity on this side. Those numbers would be more than 3 spaces away from 0. So what I'm going to do is I'm going to come right here to -3 and I'm going to put an open circle on that to say x can't be -3. But that's kind of where the things that x can be start, because anything below that -3 would also be more than 3 spaces away from 0. So I want you to look at this number line that I've drawn here. Because what I have done is on my number line, I have shown you by shading in every single number that x can be. Every single x value that is more than 3 spaces away from 0, which fits this inequality that I have up here. So if I'm anywhere on this shaded ray over here at the right, I'm more than 3 spaces away from 0. If I'm anywhere on this shaded ray over here at the left, I would also be more than 3 spaces away from 0. Now I hope as you look at this that you're seeing something that you recognize. This graph is a set of airplane wings. And we know that airplane wings go with compound inequalities. This would be an OR compound inequality. Now let's talk about the two parts of this OR compound inequality. I want you to look over here at this ray on the right first. How could I write that as an inequality? What can you tell me about all of these shaded x values over here? Well, they start out from 3. They don't include 3, but they start out from 3 and they go to the right, which means they're all greater than 3. So when I describe this ray on my graph, I can say I know, looking at it, that x has to be greater than 3. And now when I come over here and I look at my ray on the left, it starts out from -3 and then goes to the left forever. So what do I know about all of these numbers? Well, I know they're all less than a -3. So x is greater than 3 would describe this ray on the right, and x is less than -3 would describe this ray over here on the left. So this would be the solution for the absolute value of x is greater than 3. X is more than 3 spaces away from 0. If I want x to be more than 3 spaces away from 0, then x has to be greater than 3. It has to be above 3, or x has to be less than -3. It has to be below -3. Those are the numbers that are more than 3 spaces away from 0. So this would be my solution. Now, hopefully that makes sense. Now, I want to point out something to you here. And I'm going to point this out several times as we go through these examples, because this is the pattern that you are going to see continually with absolute value inequalities. I want you to look at the positive case that we have written down here. Notice again how we have a positive case and we have a negative case, just like we did with the equations. I want you to notice that the positive case looks just like the problem that we were given, with one tiny difference. And what is that tiny difference? The difference is that the absolute value bars have been removed. So this positive case should look just like the original problem, with the exception that we have removed the absolute value bars. Now what I want you to do is look at your negative case. So let's look over here at our negative case. How does this negative case that I have over here compare with my positive case? Well, this one said that x had to be greater than 3. This one says that x has to be less than a negative 3. So I want you to notice two changes have been made. Greater than has switched to less than, so the inequality sign has flipped, and positive 3 has been turned into negative 3. So your positive case should be just like your problem, with the exception that absolute value bars are removed. And then when you do your negative case, you're going to do two things. You're going to take this and flip this inequality sign, and then make this positive number a negative. So that is a pattern, like I said, that I will continue to point out to you as we do some more examples here. Now, we've looked at the absolute value of x greater than 3. Now what I want to do is look at the absolute value of x is less than 3. So two pretty simple problems here to get us started. Now, what am I taking the absolute value of? Well, I'm taking the absolute value of x. And what does this problem tell me about x? Well, what this problem tells me is that if I take the absolute value of x, it is less than 3. Now, this absolute value right here is a distance, so this is saying the distance is less than 3. So this problem is trying to tell me that x is less than 3 spaces. From 0. So this time the numbers that I choose for x need to be less than 3 spaces away from 0. All right, so right there is 0. Is 1 less than 3 spaces away? Sure. So 1 is a number that x could be. The absolute value of 1 is less than 3. What about 2? Sure, x could be 2. 2 is less than 3 spaces from 0. The absolute value of 2 is less than 3. What about 3? No. When I get to 3, the absolute value of 3 is not less than 3, it's equal to 3. But notice that that's kind of the borderline. That's where I'm exactly 3 spaces away from 0. So if I go beyond that to 4 and 5 and 6, none of those numbers are going to work here because none of those numbers are less than 3 spaces away from 0. So here's what I'm going to do. I'm going to go to 3, where I'm exactly 3 spaces away from 0, and I'm going to put an open circle to say, this is where I'm 3 spaces away, but x can't be 3, because I want to be less than 3 spaces away. If I start heading in the other direction, -1 is less than 3 spaces from 0, because it's only 1 space away. -2 is less than 3 spaces from 0, because it's only 2 spaces away. But again, once I hit -3, that's where that ends. It's not less than 3 spaces away. It's exactly 3 spaces away. So again, I'm going to come over here to -3 and put an open circle. So I want you to notice this number is significant because it gives you kind of the boundaries. 3 and -3 are going to be the boundaries. Now, which numbers are less than 3 spaces from 0? Well, the answer is it's all of these numbers in between there. All of these numbers in between there are less than 3 spaces away from 0. So notice when it's greater, we're trying to get far away from 0, so we go out to the ends of the number line. Notice when it's less than 3, we're trying to stay closer to 0, so we stay trapped in here where 0 is. So -2 is less than 3 spaces from 0. 0.5 right there is less than 3 spaces from 0. All of the numbers in this shaded area of the number line fit this description of having an absolute value that is less than 3, of being less than 3 spaces away from 0. Now again, I hope when you look at this that you're connecting it to those compound inequalities that we did last week. This would be an and. This would be an and because notice it is a car bumper. So I want you to think about all these numbers in this shaded part of the number line. How do they compare with 3? How do 2 and 1 and 0 and -1 and -2 compare with 3? Well, those numbers are all less than 3. So I could write here x is less than 3. Every single one of these numbers less than 3 is at a distance that's less than 3 spaces from 0. Then what I would want to do is look at how these numbers in this shaded part of the number line compare with negative 3. How do negative 2 and negative 1 and 0 and 1 and 2 compare with negative 3? Well, they are greater than negative 3. So this number line that I have in front of me shows that x is less than 3, and at the same time x has to be greater than negative 3. It has to meet both of those requirements in order to have an absolute value less than 3. So I want you to notice this greater than problem gave us an or compound inequality. This less than gives us an and. Now again here I want to emphasize what I was saying earlier, because I want you to see the pattern in this. Okay? I want you to look at the first part of your solution. X is less than 3. And I want you to notice that again it looks just like the problem you were given, except the absolute value bars have been removed. So the first case will be an as-is case. It'll be just like your problem without the absolute value bars. And now I want you to look at part 2, x greater than negative 3. I want you to notice again that if we compare it with this first part, two things have happened. Less than has become greater, so that sign has flipped, and then the 3 has changed to a negative 3. So that is the pattern you will notice every single time with these absolute value inequalities, is you are still going to split them into two cases, a positive case and a negative case. So let's kind of write this down. So for absolute value inequalities, you're still going to have two cases. Still going to have two cases. You are going to have your positive case and you are going to have your negative case. For the positive case, I'm going to write as is. And what I mean by that is that it is just like the problem, but without, so I'm going to abbreviate without, like that, without the absolute value bars. So just like the problem without the absolute value bars. On the negative case, we're going to make two changes. Two changes. Okay? You are going to flip the inequality sign. So when you write that negative case, you will first of all flip the inequality sign, and then the second change you will make is you will make the number negative. So these absolute value inequalities, when you solve them, are still going to require, just like the absolute value equations, that you do two cases, a positive and a negative, and this is how it will always go. Your positive case will always be an as is, so just like the problem without absolute value bars. Your negative case, you're going to make two changes in it. You're going to flip the inequality sign and make the number negative. These will be and or inequalities. These will be compound. And you know, graphing them will help you to decide which it is. All right, so there's our basic introduction. That'll get us started. Now let's start to put some other things into these problems. Kind of build on what we did in those first two basic problems. All right, in this number 3, what am I taking the absolute value of? The answer is I am taking the absolute value of x plus 6. And what do I know about that absolute value? Well, I know the absolute value of x plus 6 is greater than 7. So what this problem is telling me is that x plus 6 is more than 7 spaces from 0. Now, I'm writing this down every time I do one of these. You don't have to do that. I'm writing it down because that makes me feel better. It makes me feel like I'm showing you the details, showing you my thinking, so that as you're trying to do this at home on your own, it gives you a better picture of what's going on. Now, here's what I need you to remember. We are going to take this problem and we're going to turn it into 2 cases. So when we get an absolute value inequality, we're going to make this 2 cases. Case 1, remember, was my as is. So this says the absolute value of x plus 6 is greater than 7, but I want to lose those absolute value bars. So I'm going to come down here for case 1 and write this down as is. X plus 6 is greater than 7, but I am going to remove the absolute value bars. All right, case 2. Remember, we have to take this and make 2 changes. We have to flip the inequality sign, make the number a negative. So it's still going to start out with x plus 6, but we're going to flip this inequality sign right here from greater to less, and we're going to change this positive 7 into a negative 7. So get your case 1 by bringing the problem down without absolute value bars, and then on case 2, make the 2 changes. Take case 1, flip the inequality sign, make your number negative. All right, now, you've got your 2 cases, time to solve for x. So how would you solve this inequality for x? Well, you have x plus 6, so you would subtract 6 on both sides. And that's going to tell me that the x's in this problem can be greater than 1. All right, for case 2, I need to solve for x. So if I have x plus 6 is less than negative 7, to solve for x, I would need to subtract 6 again. So that's going to give me x is less than a negative 13. Now, right here in the middle, I'm going to need an and or an or. So to figure out which one I need, let's put this thing on a number line. So I want 0 on there. I'm going to need a 1 on there, so that'll go to the right. And I'm going to need a negative 13 on there, which will go to the left. Now, both of these are ready to graph because notice the x comes first. You're not ready to graph until the x comes first, and these both have that. So let's put x is greater than 1 on this number line. X is greater than 1 would have an open circle on 1, and then the shading going to the right of 1. Okay, now let's put x is less than a negative 13 on here. Less than a negative 13 would have an open circle on negative 13, and then the shading would go to the left side of that negative 13. So what does that look like to you? Is that a car bumper or is that airplane wings? Well, that appears to be airplane wings, so this should be an or. Now that right there is super important to me. When you get your final answers on these and you have solved your 2 cases, I want you to tell me if this is an and problem or an or. So this right here that I'm circling, that is the solution I would want to see on your paper. X can be greater than 1 or x can be less than a negative 13 in order to make the absolute value of x plus 6 greater than 7. So think about how to make these 2 cases. All right, here's the next one we'll look at. We're going to do the absolute value of 2x minus 3 is less than 19. All right, what am I taking the absolute value of? 2x minus 3. And what do I know about it? I know that the absolute value of 2x minus 3 is less than 19. So 2x minus 3 is less than 19 spaces away from 0. So to solve this problem, I need a case 1 and I need a case 2. Now here's how I'm going to do that. Case 1, I'm going to take that problem as is, with the exception that I'm going to remove those absolute value bars. So I'm going to write here for case 1 that I want 2x minus 3 to be less than 19. Write it down just like it is without the absolute value bars. Now, to get case 2, I'm going to take case 1 and make a couple of changes. I'm going to change the inequality sign and the number at the end. Notice the one thing you don't change. You do not change the first part of the problem. So it's still going to start out with 2x minus 3, but I'm going to change less than to greater than, and I'm going to change positive 19 to negative 19. So take case 1 and change the two things that you were allowed to change, the inequality sign and that final number. So your two cases for this are going to be 2x minus 3 is less than 19, 2x minus 3 greater than 19. And now we're going to solve each one of these for x. So to solve for x, we would first of all add 3. That gives us 2x is less than 22. Then we divide both sides by 2. Now remember on this, when you divide, because these are inequalities, if you divide by a negative, you will still have to use that rule of flipping the inequality sign. I don't have to do that here because I'm dividing by a positive, but I want to remind you about that. So for the first part of this problem, I find out that x can be less than 11. So if the absolute value of 2x minus 3 is less than 19, then x can be less than 11. Now let's solve this part. We'll add 3, which gives us 2x is greater than a negative 16. We divide both sides by 2. Since it's positive, we won't flip the sign. So that'll give us x is greater than a negative 8. Now, I'm going to put my number line up here this time to give me a little more space. I want 0 on there. I want positive 11. And I want negative 8. Notice that x comes first in both problems, so I'm ready to graph. So let's start with x is less than 11. For x less than 11, we would put an open circle on 11, and then the shading would go to the left. For x greater than negative 8, we would put an open circle on negative 8 and go to the right. So notice, this is going to be that car bumper situation. So what does that tell me? That tells me that this is an AND answer. X has to be less than 11 and x has to be greater than negative 8. So when I look at your solutions, I'm going to want to see that connecting word. That's really important. That's a big deal in this. So in the red box, you see the solution to this problem, and I get it by doing the two cases. The as-is positive case and the case 2 where I make the two changes I'm allowed to make. Flip the sign, make the number a negative. Those are the only two things that I'm allowed to change. So here is your solution for number 4. Now don't forget, because this is an AND, that we could condense this. We could condense this. To condense it, you would pick the inequality that has the smaller value in it, which is this one. X is greater than a negative 8, and you would flip that over. So x is greater than negative 8 would become negative 8 is less than x. And then my x is sitting there waiting for me to say that x is less than 11. So I don't have to write x again. I can just put x is less than 11 right on the end of that. So that would be my condensed version. On this number 5, we are taking the absolute value of 7 minus 4x, and that absolute value is less than or equal to 27. So that means that 7 minus 4x is less than or equal to 27 spaces from 0. So here's what we're going to do to solve this problem. We're going to do our 2 cases. Case 1 is our as-is case. So recopy this problem, leaving off the absolute value bars. So you're going to say 7 minus 4x is less than or equal to 27. Just like the problem, except for we take off those absolute value bars. Case 2, we take case 1 and change the ending. The 2 things we're allowed to change. So it's still going to say 7 minus 4x, but instead of less than or equal to, it's going to say greater than or equal to. And instead of 27, it's going to say negative 27. And now we solve. So to solve 7 minus 4x is less than or equal to 27, the first thing we will do is subtract 7 on both sides. That leaves us with negative 4x is less than or equal to 20. Then when we divide both sides by negative 4, we're dividing by a negative, we got to remember to flip the inequality sign. So that's going to go to greater than or equal to. So this is going to be x is greater than or equal to a negative 5. We'll solve case 2 the same way. We'll subtract 7, which will give us negative 4x is greater than or equal to a negative 34. And then we'll divide both sides by negative 4. Since we are dividing by a negative, we will flip the inequality sign. So that is going to be x is less than or equal to, let's see, I believe that'll reduce to 17 halves. Or if you wanted to, you could make that 8.5. I'm good either way. So there's your solutions. All right, let's get our numbers on here. We want negative 5, and then we want 8.5. We're fortunate enough that both of these are ready to graph because they both start out with x at the beginning. So for x greater than or equal to negative 5, that would require a filled-in circle, and we would go to the right. For x less than or equal to 8.5, that would require a filled-in circle, and go to the left. So notice again, this is going to be a bumper, a car bumper. So what would that make this? That would make this an and. For this inequality, here is the solution. Your x must be greater than or equal to a negative 5 and less than or equal to 8.5. It must be both. And you could condense this one if you wanted to. You would take the negative 5, the smaller value, and flip that. So rewrite that as negative 5 less than or equal to x. And then for this x, attach the less than or equal to 8.5. So that would be the condensed version. So hopefully we're catching on to this. Now, on this last problem, I'm going to write this one up, number 6. And what I'd like for you to do at this point is pause your video. So hit that pause button and try this one on your own. So I'm going to wait here for a little bit to let you pause your video and try this one. And then when you've got it done, unpause. And I will talk through the solution to this problem so you can see how you did. So pause the video, give this one a try. All right, so let's go through the solution to this one and see how you did. 2x plus 2 has to be 22 or more spaces away from 0. So what should your case 1 look like? Hopefully for your case 1 you wrote down 2x plus 2 is greater than or equal to 22. Should look exactly like the problem, but no absolute value bars. So that should have been your case 1. Now, for your case 2, I'm hoping that you wrote down 2x plus 2, because we're not allowed to change that, but I'm hoping you switched greater than or equal to less than or equal to, and made the positive 22 a negative 22. That's the way you always do these, as is, and then change the two things you're allowed to change. So here should have been your two cases. Now, solving these, they both solve the same way. We subtract 2 to get 2x is greater than or equal to 20. Divide by 2, which is a positive, so no flipping of the sign here, to get x is greater than or equal to 10. So there's half of your solution. Same steps over here, minus 2 both sides. 2x is less than or equal to a negative 24. Divide by 2 to get the x is less than or equal to, not to mess up there, x is less than or equal to a negative 12. So when you solved case 1, x should have been greater than or equal to 10. When you solved case 2, x should have been less than or equal to a negative 12. Now for your graph, both problems have x first, so we're good to graph. For x greater than or equal to 10, filled in circle, shading should go to the right because it's greater. Less than or equal to negative 12, we should have a filled in circle, and the shading should go to the left. So I'm seeing airplane wings, so that should have been an or. So solution for this problem should be x is greater than or equal to 10, or x is less than or equal to a negative 12. So two cases. Case 1 as is. Case 2, change the sign and the number. Those are the two things you're allowed to change. All right, I think you have 8 problems to do today, solving absolute value inequalities. This is Friday for you, so hope you'll have a great weekend. And then next week, we will start off our week with absolute value inequalities that have stuff outside the absolute value. So that's what's coming up next. Continue to keep me posted on how you're doing. So if you have questions, don't hesitate to let me know. Thanks a bunch and have a great weekend.